So it said that a particle is projected at 40 meter per second at 40 degree to the horizontal. So angle of projection is 40 degree and the velocity is 40 meter per second. We need to find the range, that means how far it goes, and the maximum height it reaches. So the travel path will be like this. So we need to find when it again hits the ground, that is, this is the range, and how far it goes, the maximum, how high it goes, maximum height basically. So the velocity, the initial velocity will have two components, horizontal, vertical one and horizontal one. U cos alpha will be the horizontal and U sin alpha will be the vertical one. So U is 40 and alpha is also 40 degree. So this one, which is the horizontal one, U cos alpha, will be constant throughout. It won't change throughout the travel path. But the vertical one will be affected by gravitational acceleration. So initially it will, when it's thrown up to its maximum height, because of the gravitational pull, it will start to decelerate. It will keep decelerating. Here the velocity will become 0. After that it will accelerate downwards and it will reach the ground, the vertical component only. So when it reaches the maximum height, the vertical velocity becomes 0, vertical component of the velocity. So that's a thing. If we remember this equation, v square is equal to u square minus 2gs, in this case we can say h, if we remember that, and here it will be only vertical one. So the final velocity when it reaches maximum height, it will be 0. So initial one will be, of course, u sine, we have to remember that this is only the vertical component, minus 2g times h. So from here we can find the maximum height from this equation, because this is the distance. We are considering only the vertical movement here. So this will be u sine alpha whole square over 2 times g. So this will be 40 sine 40 degree, 40 degree square over 2 into 9.8, since it's in MKS unit. So that will be 33.73 meters. So that's the maximum height. Now we need to find the range. That means how far away it falls in the ground basically. So what we can do, first we can find when it reaches the maximum height. So we can go to another equation, which is u minus gt, v is equal to u minus gt, and from here we can find the time when it reaches the maximum height. So v again will be 0 at the maximum height. So initial velocity is u sine alpha. This is v, basically v sine alpha, and that becomes 0 at maximum height. V cos alpha or u cos alpha, that is the horizontal component, is constant throughout the travel. So this is g times t. T we need to find out. So u sine alpha over g. So that's 40 sine 40 degree over 9.8. That is 2.62 seconds approximately. So that's the half of the travel time. So the full travel time will be, of course, if we say capital T or uppercase T, it will be 2 times T, which is 2.62. So that's 5.24 seconds. Now we need to find the range. If we call it r, it will be u cos alpha, which is the horizontal velocity, which remains constant throughout, times the travel time. That will be the range, which is how far away it falls on the ground. So that will be, of course, again 40 cos 40 degree times 5.24 approximately. That's approximately 161 meter basically. So that's the range here.